A pleasant day to the Laboratory High School Grade 10 Galileo of NEUST San Isidro Campus. This day we'll be discussing part of our lesson 1, which is the geometric sequences. Okay, let us start with the warm-up exercise because this would help you in solving geometric sequences. Find the value of each expression. Number 1, 2 raised to 5. What is the answer? So that is 32 because 2 raised to 5 means 2 times 2 times 2 times 2 times 2. You multiply 2 5 times to itself and the answer is 32. Number 2, 2 raised to negative 5 is equivalent to 1 over 32. If the exponent is negative, to make it a positive 1, we move it to the denominator. Or if it is in the denominator, to make it a positive exponent, we move it to the numerator. So the answer here is 1 over 32. Number 3, negative 3 raised to 4. So that is negative 81. Why? Because in this expression, the only number being raised to 4 is 3 and negative is not included. So you raise 3 to 4, that is 81, and then rewrite negative. For number 4, the quantity of negative 3 raised to 4, that's the difference, is equal to positive 81 because the whole negative 3, even the sign, is being raised to 4. And negative times negative times negative times negative is equal to positive. Number 5, 0.2 raised to 3 is equal to 0.008. Number 6 is 7 times negative 4 squared is equal to 112 because you have to first solve for negative 4 squared and that is equal to 16 times 7 is 112. For number 7, that is equivalent to 5 over 9. Since 1 over 3 cubed is equal to 1 over 27. Since 3 times 3 times 3 is 27. Then multiply it to 15. So you will have 15 over 27. Then simplifying it further, since 15 and 27 are both divisible by 3. So you'll have 5 over 9. For number 8, that is 12 times negative 0.4 raised to 3. You multiply negative 0.4 to itself 3 times and then after getting the product, you multiply it by 12 which is equal to negative 0.768. Okay. So the objectives of this presentation of this video lesson are the following. Recognize and extend geometric sequences. Find the nth term of a geometric sequence. By the way, this PowerPoint presentation is from Holt McDougall Algebra 1. The vocabulary, geometric sequence and common ratio. When we say geometric sequence, ito yung sequence na tinitingnan natin. Ano, katulad dun sa arithmetic sequence, di ba meron tayo dun, hinahati siya ng comma, kaya siya tinawag na sequence. But the difference in geometric sequence is that mayroon siyang common ratio. Hindi katulad sa arithmetic sequence na ang mayroon siya ay common difference. So that's the difference between geometric sequence and arithmetic sequence. So the table shows the heights of a bungee jumper's bounces. So do you know the bungee jumping? So it's a recreational game. Yeah. So as you can see, bounce 1, 2, 3, then height 280 and 32. So sa unang bounce, yung ating jumper, ang naabot niya ay 200 feet. Siyempre sa pangalawang bounce, medyo hihina na yon, kaya ang naabot na lang niya o ang naging height na lang niya ay 80. And then sa pangatlo na bounce, dahil pahina siya ng pahina, so nagiging mababa din yung nare-reach niya na height. So 32 na lang. So the height of the bounces shown in the table above form a geometric sequence. So meron daw na form na geometric sequence dyan sa table na yan. In a geometric sequence, the ratio of successive terms in the same number R called the common ratio. So R naman ang gagamitin natin dito. No? Instead of sa arithmetic sequence, we use D for common difference. Here, in geometric sequence, we use R. So, titingnan natin, ano ba ang common ratio? So, geometric sequences can be thought of as functions. The term number or position in the sequence is the input and the term itself is the output. Alright. So, talaga naman function siya, no? Kasi nagbabago ang sequence depende dun sa pagbabago ng input. So, ang input natin dito, yung ilan yung talon ng isang jumper. Tapos, ang output natin dito ay gaano kataas yung inaabot ng talon niya. So, yeah. So, 1, 2, 3, 4, the position. Okay. And then, 3, 6, 12, 24. Alright, so in this example, these are our inputs, the positions of our sequence, and these are the terms. So the terms of the geometric sequence are 3, 6, 12, and 24. So we have here 4 terms in the geometric sequence. So we call it first term or A sub 1, A sub 2, A sub 3, and A sub 4. To find a term in a geometric sequence, multiply the previous term by R. So R is the geometric ratio. In this case, as we can see, what is our multiplier to get the next term? So upon observation, 3 became 6, meaning we multiply 3 by 2, so you'll have 6. And then 6 by 2 is 12, then 12 by 2 is 24. So that means that our common ratio here is equal to 2. So to get the next term, we multiply 24 by 2, and that is equal to 48. Finding a term of a geometric sequence. The nth term of a geometric sequence with common ratio R is A sub n is equal to A sub n minus 1 times R. So this is how can you solve for the term of a geometric sequence. Papaano ninyo makukuha yung hinahanap na geometric sequence? So that is only A sub n equals A sub n minus 1 times R. Writing math. The variable A is often used to represent terms in a sequence because even in arithmetic sequence, we use A. The variable A sub 4, you read it as A sub 4, is the fourth term in a sequence. So A sub 4, that means the fourth term of the sequence. If you have A sub 10, that means A sub 10 is the 10th term of the sequence. Example, extending geometric sequences. Find the next 3 terms in the geometric sequence, 1, 4, 16, 64. So our first task is to find the value of R by dividing each term by the one before it. So how can we solve for the R? You divide the 2 consecutive terms in the sequence for you to get the common ratio. Let us try. 4 divided by 1 is equal to 4. 16 divided by 4 is equal to 4 also. Then 64 divided by 16 is also equal to 4. And that means that the R here or the common ratio is equal to 4. There you go. Example 1 continued. Find the next 3 terms in the geometric sequence. So after getting the common ratio, which is 4, we can now identify the next 3 terms in the geometric sequence. We multiply each term by 4 to find the next 3 terms. So 64 times 4 is equal to 256. Then 256 times 1024 is equal to 4096. And then A sub n is equal to A sub n minus R times R. The next 3 terms are 256, 1024, and 4096. So that's in this formula, that's a sub n is equal to a sub n minus 1 times r. Example 1b. Extending geometric sequences. Again, find the next three terms in the geometric sequence. What is the first step? The first step is to identify the common ratio by dividing the two consecutive terms. So in this case, we have 3 divided by negative 9. So you will have 3 divided by negative 9 is equal to negative 1/3. And then negative 1 divided by 3 is equal to negative 1/3. Then 1/3 divided by negative 1 is equal to negative 1/3. So that means our common ratio, or the value of r, is equal to negative 1/3. When the term in a geometric sequence alternate between positive and negative, the value of r is negative. Upon observation, if you look into the geometric sequence and you observe that the sequence do have an alternate negative and positive values or terms, then automatically your r is equal to negative. Okay? Pag nakita nyo na magkasunod ay isang positive at isang negative, positive, negative, meron siyang alternate na signs, then automatically the r, or the common ratio, is a negative 1. Yun yung palatandaan ninyo doon. Find the next three terms in the geometric sequence. So that's our task. And we know that the common ratio is equal to negative 1/3. So we multiply negative 1/3 to negative 1/9 to get the next term. So negative 1/9 times negative 1/3 will become positive 1/27 times negative 1/3 is equal to negative 1/81 times negative 1/3 is equal to positive 1/243. So again, a sub n is equal to a sub n minus 1 times r. So the next three terms are those: 1/27, negative 1/81, and 1/243. Find the next three terms in the geometric sequence. Again, we have here 5, negative 10, 20, negative 40. Okay, our first step is to find the common ratio by dividing the two consecutive terms. So you will have this. Negative 10 divided by 5 is equal to negative 2. 20 by negative 10 is negative 2. So the common ratio is negative 2. And as you can see, we have an alternate sequence here. Positive, negative, positive, negative. So the common ratio is automatically a negative 1. So the value of r is negative 2. And we are asked to solve for the next three terms in the geometric sequence. So we multiply negative 40 by the common ratio, which is negative 2. So you will have positive 80 times negative 2 is equal to negative 160 times negative 2 is equal to 320. So the next three terms are 80, negative 160, and 320. Another example, find the next three terms in the geometric sequence. So the first step is to find the common ratio, or r, by dividing it. So you will have 384 divided by 512 is equal to 3/4. And then 288 divided by 384 is also equal to 3/4. So our common ratio is equal to 3/4. Or in decimal, that is 0.75. So our multiplier would be 0.75. Multiply 288 by 0.75. If we multiply it, so you will have these terms. 288 times 0.75 is equal to 216. 288 times 0.75 is 216. Then 216 times 0.75 is equal to 162. And then 162 times 0.75 is equal to 121.5. So that means that the next three terms of the geometric sequence are 216 or 216, 162, and 121.5. To find the output a sub n of a geometric sequence, when n is a large number, you need an equation or function rule. So you already know how to solve for the common ratio of the geometric sequence. You simply divide the two consecutive terms and check it whether they are common to all. So the pattern in the table shows that to get the n term, multiply the first term by the common ratio raised to the power n minus 1. So first term is 3, so that is a sub 1. Our second term is a sub 1 times r raised to 1. So here we have r raised to 0, right? So r raised to 0 because 1 minus 1 is 0 and r raised to 0 is equal to 1. So a sub 1 times 1 is equal to a sub 1. And then the second term is a sub 1 times r sub 1. So example, 3 times 2 raised to 2 minus 1 which is 1. So ito yung 2 na yan yung ating common ratio. And then yung exponent na ito, nanggaling yan sa dahil second term siya, minus 1, n minus 1. So that is 2 minus 1 which is 1. And then 3 minus 1 which is 2. Then 4 minus 1 is 3 and so on and so forth. So if the first term of a geometric sequence is a sub 1, then the n term is a sub n and the common ratio is r. So our equation would be a sub n equals a sub 1 times r raised to n minus 1. Where n is the n term, a sub 1 is the first term, and r is the common ratio. Okay, let us have this example. Finding the n term of a geometric sequence. Find the first term of a geometric sequence. The first term of a geometric sequence is 500, so that is the first term, a sub 1. And the common ratio is 0.2, that is r. What is the seventh term of the sequence? So we write the formula. The formula is a sub n equals a sub 1 times r raised to n minus 1. And then substitute 500 to a sub 1, then 7 for n, and 0.2 for r. So by substitution, you will have this. A sub n will become a sub 7 since we are solving for a sub 7. And then a sub 1, the first term is 500, times the common ratio which is 0.2 raised to n which is 7 minus 1. Simplifying it further, you will have 500 times 0.2 raised to 6 since 7 minus 1 is equal to 6. Then simplifying it further using your calculator, you will have 0.032. So you raise first 0.2 to 6, then multiply it to 500. So the seventh term of the sequence is equal to 0.032. For a geometric sequence, first term is 5 and r equals 2. Find the sixth term of the sequence. So again, write the formula and then substitute 5 for a sub 1 since that's the first term. Then 6 for n since we are looking for the sixth term, and 2 for r because 2 is the common ratio. So there you go. A sub 6 is equal to 5 times 2 raised to 6 minus 1. Then simplify the exponent, so you'll have 5 times 2 raised to 5. And what is 2 raised to 5? 2, 4, 8, 16, 32 times 5 is equal to 160. Meaning, the sixth term of this geometric sequence is equal to 160. Example, another example, find the nth term of a geometric sequence. So we are looking for the ninth term of the geometric sequence 2, negative 6, 18, negative 54. Paano mo makukuha yung ninth term na hindi mo na yan iisa-isahing multiply? Yan. So the common ratio is negative 3. So that is the value of R. So we write our formula and then substitute 2 for a sub 1 since that is the first term of the geometric sequence from the given. Then 9 for n since we are looking for the n term, and negative 3 for the common ratio. Then simplifying it, simplify the exponent, so you will have 2 times negative 3 raised to a, and then using your calculator, you will have 13,122. So that is the 9th term of the geometric sequence. Caution: when writing a function rule for a sequence with a negative common ratio, remember to enclose r in parentheses. So negative 2 raised to 12 is not equal to the quantity of negative 2 raised to 12. They are different. What you will be getting in the first expression here at the left side is negative 1, while what you will be getting from here is a positive 1, and a positive and a negative integer are different, are two different integers. So check it out. What is the a term of the sequence 1,000, 500, 250, 125? So what we want to know here is the eighth term. So you find first the common ratio by dividing the terms. So you will have 1/2. Since 500 divided by 1,000 is 1/2, 250 by 500 is 1/2, 125 by 250 is 1/2. And please take note that you do the division like this. Do not do the division as 1,000 divided by 500. Mamamali kayo doon, ano? So dapat unahin nyo muna yung pangalawang term, siya yung dividend, at ang divisor ay yung second term to get the common ratio, because 1/2 and 2 are two different numbers. Then write the formula, then substitute the values, the known variables here. You know that 1,000 is our first term, 8 is our n because we are looking for the a term, and 1/2 for r. Then simplify the exponent. So you will have 100 times 1/2 raised to 7. Then using your calculator, you will get 7.8125, which is the eighth term of this geometric sequence. So here is an example, application. A ball is dropped from a tower. The table shows the heights of the ball's bounces, which form a geometric sequence. What is the height of the sixth bounce? Di ba pagka meron tayong bola, pinatalbog mo yan, sa unang talbog, yun yung pinakamataas niyang mali-reach. So sa first bounce niya, 300 yung na-reach niya. Sa second, pangalawang talbog, 150, and then sa pangatlong bounce niya, 75. Ang itinatanong sa atin ay yung pang-sixth bounce. So first, we find the common ratio. So the common ratio is 0.541/2. So that is the value of our r. Then write the formula and then substitute 300 for a sub 1 since that is the first term of the geometric sequence. Then 6 for n since we are looking for the sixth bounce, and 0.5 for r because that is our common ratio. And then simplify the exponent, so you will have 300 times 0.5 raised to 5. Using your calculator, simplify it and you will get 9.375, which is the sixth term of the geometric sequence. So check it out, example 3. The table shows a car's value for 3 years after it is purchased. The values form a geometric sequence. How much will the car be worth in the 10th year? Of course, meron tayo talagang law dyan, ano, na habang tumatagal ang ating mga sasakyan, mas bumababa ang kanilang mga value. Nagdi-differentiate siya, no? So, sa year 1, $10,000 pa siya. Sa year 2, $8,000 na lang siya. And then sa year 3, $6,400 na lang siya, no? And then, what we are looking for is the value of the car at the 10th year. So, our first task is to identify the common ratio, which is 0.8 by dividing the terms. So that is the value of R. And then write the formula, then substitute 10,000 for A sub 1, 10 for N, and 0.8 for R. So 10,000 is the first term, 10 is for N since we are looking for the 10th year value of the car, and 0.8 is the common ratio, the one that we got earlier. And then by substitution, you will have that, then simplify the exponent. So you will have 10,000 times 0.8 raised to 9. Then using your calculator, you multiply and simplify the exponent. You will have 1,342.18. So that means that after 10 years, at the 10th year, the car will be worth 1,342.18 US dollars. Okay, so we have here a lesson quiz, part 1. If you want to answer this, or I will actually be requiring you to answer this in your lecture notebook, just pause this video and then while you are solving, and then after solving, just continue to check whether your answer is right or wrong. So this is just a practice exercise. Find the next 3 terms in each geometric sequence. Let's have number 1. We have 3, 15, 75, 375. So you get the common ratio, 15 divided by 3. So the common ratio is 5. So you simply multiply this term to 5 to get the next term, then multiply by 5, and then another 5. So you will get these 3 terms. Next, negative 1 and 5, you divide it, so you will have negative 1/5. So our common ratio is negative 1/5. So it's an alternate sequence. So you will have negative 1 over 625, 1 over 3125, and negative 1 over 15625. Number 3, the first term of a geometric sequence is 300 and the common ratio is 0.6. What is the 7th term of the sequence? So we'll be using the formula here. Upon using the formula and substituting all the known variables, you will get an answer of 13.9968. For number 4, what is the 15th term of the sequence? 4, negative 8, 16, negative 32, and 64. So our common ratio here is a negative 1. So negative 8 by 4 is negative 2. So the common ratio is negative 2. And then using those variables, substitute all those into our formula to get the 15th term. And that is equal to 65,536. How many points do you got? Okay. For the part 2, if you want to solve this, just pause the video and just continue if you want to check it. The table shows a car's value for 3 years after it is purchased. The values form a geometric sequence. How much will the car be worth after 8 years? In the first year, the value of the car is 18,000 pesos. Second year, that's 15,300, and the third year, it's 13,005. So the first step is to identify your common ratio and then substitute the values into the formula to get your answer, which is 5,570.39. So that means that the value of the car in the 8th year is equal to 5,570.39. And that is how you use the formula in finding or solving geometric sequences. If you have any more questions with regards to what we discussed today, just send me a message in our group chat and I'll be answering all of those. For the meantime, thank you very much. Keep safe and stay at your home.